quick. So we're going to show you identity and access management, multiple clouds, but one identity and access management system to get to all of them. We're going to use Auth0 for this, but you could insert anything that you want on that. We're going to show you how you manage across multiple clouds with our console. So our console is something that we developed over the last year and a half. It's a constantly growing and iterating part of our product line. We learned from the best in terms of vSphere, in terms of looking at that user interface and trying to understand how you make this simple, no matter how complex the task may be. And then we're going to show you one application across multiple clouds, right? So talking about changing your bucket names, not changing a single line of code as you move from cloud to cloud.
Since you went through your various different cloud providers, you mentioned all of the hyperscalers, and you mentioned Tanzu, which is in itself a hybrid container experience. Will you talk about methods of consuming private cloud?
From MinIO's point of view, it's just from our underneath, whether it's a Supermicro box running a OpenShift or MinIO on GKE or AKS, we really don't differentiate, right? There are actually customers who are using OpenShift and MinIO inside AWS because they want to have the same software stack on their hybrid cloud environment. For us, it doesn't really matter at all. We tell the customer, we are not even in a place to recommend HCL, right? We are pretty much almost all the time operating at the layer above the Kubernetes that is containers, and how we get deployed, they already have usually Kubernetes environment up and running, and we just roll it out.
Okay, so you would be counting on somebody's local Kubernetes environment to actually produce
correct
object store.
Exactly.
If you were using local storage.
Yes, and like VMware, for example, VMware 7.1 onwards, VMware actually ships MinIO as part of vSphere. It runs in a high privileged container, and from inside vSphere vCenter console, you can actually just start creating tenants and provisioning. You just set the limits. Fairly easy to drive. You don't have to ever leave the vCenter console.
Okay.
Hi, my name is Daniel Valdivia. I'm an engineer here at MinIO. And I'll be walking out over the things that Jonathan was talking about. Also, I'll be touching on a lot of the questions that Kate was posting, mainly like the multi-cloud that we keep talking about. Like how my demo is structured. First, I'm showing you how I actually deploy the same piece of software, in our case, the MinIO operator, on different flavors of Kubernetes, right? So I have, my first is GKE, right? You cannot tell because I already put a pre-domain on top of it. I have an EKS, right? Same EKS is on top of Amazon. And then I have on top of Azure on their AKS solution. And how I'm gluing them all together, right? How I'm like managing going from one to another through a simple single sign-on, right? So I'm just hopping into the instance via single sign-on. And you can see that for this tenant, I have already a few tenants, right? Tenant is the structure that we use to describe a MinIO deployment. They can have different size and different configuration. If I go into my EKS, right, I have a single tenant over there, or yes, I have a single tenant. I actually call them by their cloud, which I'm deploying them on. And on Azure, it's the same story. So you can see how deploying the same piece of software across all these clouds, I'm going to get a consistent experience across all of them. And there's no complexity into like, how do I get into this one? How do I get into that one? I can glue them to the same external identity provider that I'm using on my organization. In this case, we chose an OpenID type of solution, right? Auth0, as Jonathan mentioned, but we could also work with Active Directory, right? So the idea here is we already started standardizing, right? How you actually go and consume object storage across your organization. Doesn't matter where it's actually deployed, right? You will get the same exact experience if you were deploying, let's say, on a Tanzu cluster, on a vSphere cluster, on OpenShift, or even on premise, right? If you're just doing upstream Kubernetes on premise, you will get a consistent experience as well, right? So this is the MinIO object storage, the MinIO operator. And as I was mentioning before, this is a very easy way to actually manage infrastructure, right? So here I'm actually deploying some MinIO services, right? I have a production storage. And I think the best way to understand a tenant is deploying one. So what I'm going to do is I'm going to hit create tenant, right? I'm going to start creating a new tenant. So first, what I'm going to do is name it, right? So let's say this is my big data storage. And I'll be placing this on a namespace. So I'm going to create a namespace for this. And then I'll be just sizing this thing, right? So how big do I want my tenant to be, right? So this is where inside AWS, I'm already taking my EC2 infrastructure and slicing it into multiple tenants to serve different customers or different business units. And I just need to say, well, this is for big data deployment. I could say, well, I'll be doing initially 100 terabytes for these guys, right? So I can pick the number of servers that I'll be getting, the number of volumes that I'll be attaching to each of these servers, right? To increase both the density and the throughput that I'm getting from this deployment. And then I can pick the erasure coding parity value, right? So erasure coding is how we protect the data on MinIO. And this value actually impacts how much usable data you end up having, right? After availability. So for example, if I go with the highest value of EC8, you'll see that out of my 100 terabytes of raw capacity, I end up only 50 terabytes of usable capacity. So if I go to some smaller value, right, EC4, for example, this will yield me out of my 100 terabytes of usable capacity, of raw capacity, 75. Now, this will decrease the number of server failures I can tolerate, right? How many servers can go down and still server be up. But you get an idea, right? So it's all about the self-service and all understanding the type of SLA that you'll be providing to your own customers, whether they're internal or external. So other things you can configure in this interface, for example, I could say, I want to configure the Docker images that I'm using, right? So I could actually say, I'll be using a private Docker registry, which is pretty common nowadays. I can control the pod placement based on the infrastructure. I already show you integrating with an OpenID, right? So I could also configure it for this one tenant. Perhaps I don't need an external identity provider because it's for some testing. Perhaps I want to use OpenID or Active Directory LDAP. All of these are things I can configure. And if you see, I'm not actually having to craft any YAML, right? Not that you can't. You can actually, if you prefer doing crafting YAMLs and going through the CLI route, you can. But this UI is all about discovering these features, self-service, right? So you don't need to know how to spell Kubernetes to actually use it. And continuing on this, I can configure encryption, TLS for certificates, or for example, encryption at rest. And this is where we can actually standardize, right? Because all across these clouds, you get different KMSs available. And we support the 5 most popular KMSs out there. In this case, HashiCorp Vault is a KMS that you can deploy anywhere if you want to deploy a consistent, again, KMS experience across these clouds. Or you could use every tenant for every cloud, the local KMS if you want. So for example, since I'm deploying on AWS, I could use AWS KMS or Gemalto or Google Cloud or Azure, right? So this is where every cloud, I could decide where I want to be leveraging some of the services from the cloud in an easy fashion, or if I want to be bringing my own infrastructure to secure the whole thing. So, I mean, you get the idea. It's all about this stage, this interface is helping me orchestrate infrastructure, and I'm only concerned about infrastructure in this sense. So what I'm going to do is pretty much, I'm going to make this smaller so I don't get built too much on cloud. And I'm going to go ahead and create this tenant. Now, this is going to take a couple of minutes, and now my tenant is going to be provisioned. So it's that simple, right? It's not about, I don't need to understand or be certified on this specific cloud. Kubernetes sitting on top of this cloud provider will take care of the rest, right? I'll be provision VMs, or if I have some autoscalers, I'll be provision volumes, and that's about it. So now I could show you this one more time on Azure and Google Cloud, and I guarantee you won't tell the difference, right? So after this, while this is getting deployed, it's going to take a couple of minutes. I could show you, right? So as a tenant is getting deployed, I could see like the intricate details of this. And if you see I'm as the owner of the infrastructure, this is pretty much all things I care is how is this guy doing? How healthy this guy is? Is there any traffic going on? Is it getting full? Do I need to rotate certificates, etc.? Additionally, I could hop into this tenant, right, and do some activity. And this is where the MinIO management console comes into place. So if I, again, switch to a management console for this one tenant, and I can, again, this tenant I already prepared with single sign-on, so I'm logging in, and I'm immediately getting greeted by another user interface from MinIO. This one's specific to object storage. And again, it's the same experience that I've been telling you about. So it doesn't matter where you're running this, right? So if whether it's on Tanzu or on-premise, you'll be getting the same features, right? So this is where even people who are not familiar with the CLI can then go and discover their own features. For example, if I want to create a bucket, I can even discover them, right? So let's say this is a bucket for I'll be storing my data sets over here, right? So I can turn on versioning, right? So if I need versioning, right? Or object locking, this is how I want to protect my data from being changed, right? But of course, this is also like a great ransomware protection. I can protect my data from being modified or tampered with through object locking, but perhaps I don't want to keep the data all the time, so I can enforce a data retention policy and say, well, after 180 days, perhaps my data can be deleted. So I can also turn on a hard quota on this bucket. If I wish to just share with different teams, let's say a data science team is requesting some object storage, and I don't want to go through provisioning a whole tenant for them. I can just share now through a bucket, right? Say, I'll be giving you a terabyte of capacity or 2 or so how much. And when you're running out of capacity, come back to me, I'll give you more. So you get the general idea about how this user interface unlocks people, especially IT, understanding, being in total control of the infrastructure from the operational part on Kubernetes. And then when it comes to the object storage administration, they can also own that part, or they can completely delegate that to the applications team, which is actually in need of this part.
Who's this whole interface designed for? Because it seems on the one hand, you'd have like DevOps people who would be much more interested in CLI and API. Mm-hmm. And this seems very, very, as you mentioned at the beginning, vSphere and enterprise focused. So would those DevOps people ever get into this or not?
Yeah. So that's a great question, because if you think about it, at some point, the infrastructure people, they perhaps only care about, how many machines I'm running the service with compliance. Like, I'm going to be running this with our identity provider that the corporation specifies, and also with some encryption. But that's all they care about, right? So the application teams actually have a different agenda from them, right? They do care about the policies and which application is going to be accessing what. So, I mean, the infrastructure people could still be involved in that part, or they can completely delegate it. So that's why we separated the user interface, and you don't see us cramping all the object storage capability into this part. So to answer the question again, we want to minimize at the end of the day, this first part is still managing only infrastructure, which is what the IT departments are highly familiar with, right? They don't have to learn again all the intrinsic details of object storage if they don't want to, right? So the actual consumer for object storage is the one who's going to be more familiar with those APIs, and they can actually consume them themselves, or they could also come to a user interface, which is the same experience you will get if you go through, let's say, Amazon's console, Google's console, or the Azure portal.
Yeah, so we originally designed this for extending the reach beyond the DevOps and SREs. How can object storage will be only successful if some average technician, say I was a Comcast dish technician, I want to now get a job in IT. Can I get a job? If product is not simple enough to train them to get a job, I won't reach the scale that traditional enterprise market is. That was the original idea for us to actually bring in this console, so both enterprise IT world and DevOps SRE can coexist. To our surprise, what we learned was the DevOps and SREs actually learn how to do it right the first time, discover the capabilities on the console, and then they see themselves repeatedly doing the same things, then they go back. Like if you see, first time I'm provisioning the tenant the right way, interactively, and then the YAML file this time tells that everything you did through the console. You're doing this all the time. You don't want to be man in the middle provisioning infrastructure. That's not cloud. You want to be fully automated. So the tenant creation should be automated when the applications are rolled out. And this YAML is just a CRD. The console is built on top of the API foundation that was hardened. So they all can coexist. And this has actually helped us. And to be precise, like one problem that S3 is facing, that is Amazon S3, Amazon now talks, this is Amazon's own feedback on S3. S3 is no longer simple. And we actually know that too, that as it brought in the enterprise capabilities, now it is no longer simple get put, it has rich functionalities. But to me, if the day I told you that you need MinIO, you need to join MinIO University and get training and certification, I lost our way. And how can we make it so simple that anyone, without reading documentation, can actually, without any certification, consumer grade can adopt MinIO? This actually is the solution or the cure to the complexity that S3 has built over time. And it's something MinIO also has to suffer because we have to be neck to neck with S3 in terms of compatibility and capability. But I don't want to be let down by S3's complexity. Console addressed it.
Yeah, I'm actually really relieved to hear this because I thought it was only like cavemen like me that use the GUI and then copy the YAML out of the back end and say, I'm going to replicate that again and again, instead of just writing the YAML like a real programmer.
Sometimes the community I see that they call MinIO as MC server. MC is the MinIO client. They love MC so much that they do all the DevOps automation scripting around that and the MinIO Go package. And they would look at the server as MC server. And I take that as a compliment.
With all of this part, and you see, this is the core component. This YAML that we have here on the screen is the one component that you can actually take and copy to any other location where you are deploying your infrastructure and get the same consistent result, right? So that's why it's quite important. You don't see any, is the AWS terminology here. Actually, this is my Google tenant. You don't see any Google terminology here involved. It's all pure Kubernetes, right? And that's how Kubernetes been as the platform of the internet now, making standardizing operations as well. So I can do exactly the same anywhere where I'm actually running my infrastructure, right? So, and this opens interesting use cases. For example, here I have this Google bucket, right? So I place a bunch of files here. And more interestingly, I placed a machine learning model over here, right? I copy the same model over to my Amazon bucket and my Azure bucket, right? So I'm just showing you the same thing 3 times. But what I'm getting with this, right, is that if I have applications that are, like Avi was mentioning, stateless, and they're actually doing all their behavior through the object storage, I can pretty much deploy the exact same application on any of these clouds and get in business, right? So for this one demo, I actually wrote a simple application. I call it the object storage object detector. And pretty much it's a simple container, right? It uses TensorFlow, and TensorFlow, being a great AI machine learning framework, has native integration with object storage. So it can actually read the model straight from there. I just need to tell it the endpoint and the bucket, right? So here I actually deployed to EKS, and I'm reading out of my Amazon bucket. I have the exact same application deployed on Google Cloud, right? So on Google Cloud, I have the same endpoint and different Google bucket. And then I can just pretty much go and test this application as if it's working as expected. Let's say I have here a picture of me and my daughter. And I want to see what's in this picture, right? Because I'm losing my humanity. So I need to know or be reminded that this is what usually people see. And this application can also be, as I'm deploying it on any other cloud, let's say I have here some other random picture. And I want to be able to figure out things that are here. I didn't have to change anything about this code, right? So again, I'm standardizing operations. The same software that I have on one cloud can actually work on any other cloud, right? So no changes needed.
Now, on that part, on the back end in production, it's not just deploying the application on all the clouds, it's also replicating the data across the clouds so that when my Amazon region decides to go out, I can point my DNS at the copy I have in Google Cloud. Mm-hmm. So how would I go about doing the replication side in this configuration?
Because that's quite important. What if a cloud goes down? My applications can fail over, and that's part of the things that you can see. This application could easily just have been fail over between Google and Amazon right now. No changes needed, right? So I would just need to set up my DNS that way, or my applications load balancer that way, and that would pretty much do it, right? I also took a quick picture before starting this, so you can see this thing even running on images that it has never seen before. I took this tiny cat, and you can see it still works. So it's that straightforward, right? So this is a simple application, but let's say this is the core of my business. And I need it to be available everywhere, right? And it needs to be also on the right cloud for the region that I need to deploy. Let's say this is the service that I'm providing my customers, and perhaps my customer now it's on Asia, and I need a data center in Asia to have low latency to them. I can take my MinIO operator, deploy there, and be online within minutes.